Alright. So I think that'll be alright for what we want to do. Maybe I should have the fall speed as a parameter as well. So we'll have this as a convert to parameter. We're going to have water speed, default value of 1. Alright, water speed will be in there, and we need to duplicate this thing. Water speed. This will be, this controls how fast the water falls. So it's going to be from like 0 to like 4 or something. Default of 1. See how that goes. Alright, so it's in here. We need to make float 2. Yeah, this is what we need to do. So we'll multiply this by -1. Alright. So we should now be able to change the water speed. Or not? Alright. It's not actually... We didn't hook up the water speed. We hooked up the water opacity. Alright, just change that then. And that might work better, having a slower fall effect if the water was, more calm. A slower fall would actually look just fine. Even though it's not like falling slower, it would just, the changes would be more gradual or something. Would there be anything else that we'd want to mess with to expose for the waterfall? For the model itself. I mean, we can go back and add a whole bunch of other stuff. Well, on the edges of these things right here, we have, kind of an outline on this thing. Would it be worthwhile trying to get some sort of outline effect on this? Like, you know, something where closer to the edge that it gets brighter, or that there's some sort of thing with that? Would it be worth anything? I mean, we could do some sort of like, well, the outer 5% or something has a slightly modified color, like have a two-tone waterfall, right? Or like there's an inner color and an outer color. I'm not sure what the hell that would even really do, but it's something we could try. Alright, so the red channel is the U. No, the red channel is the V. Is it? No. Red goes from 1 to 0? Alright, let's see. This is V. This goes from 0 to 1. And then the red goes from 0 to 1 over here. So we'd want to get like from... if we wanted to blend together these colors or something. Yeah, this goes from 0 to 1 right there. So we grab this guy, and what we do is we'd subtract. We grab this guy. If we subtracted, we clamp from 0 to 1, I guess, but it's already clamped there. If we subtract 0.5, it goes from 0 to 0.5 over there. If we take the absolute value of it, we get something that looks like this. And basically, then we just multiply it by 2. So it goes from 1 to 0 back to 1. And then we just take these two colors and we take we need some more multiplies here. So multiply this color and this color. So this color is going to get multiplied out. The base color will be the this one's going to be the negate 1. So we do this multiply, and then we do the add. We slap these together here, and then we can throw that right in there. So let's take this and let's make it a lighter color. So we've got kind of this inside-outside sort of waterfall effect. Well, let's see what it looks like. Closer, we'd want now basically a width for this sort of thing in it. And this is also, like, you can do inside of material stuff with all sorts of colors and crazy bullshit. What you could also do in like Photoshop and just be like, I want to change the texture for this waterfall. And this might be a symptom of like, I've kind of done what I should be doing inside of material land, and the rest of it's just like, hey, you know, make a cool looking waterfall. So if we wanted only the outside, so if we had like some sort of width there. Let's think for a second. Like if this goes from negative 0.5 to 0 to 0.5, I want to remap it so it goes from like negative that the edges are smaller. Well, what I could do is do like an invert or something. If we multiply it by 2, it goes from 1 to 0 to 1. If we multiplied it by itself, yeah, we can multiply it by itself and then invert it. And that should kind of do what we want. We multiplied it by itself, inverted it. Why does it have this curve? Alright, so this is 1 to 0 to 1. Multiply by this color. Oh, well, it should have the curve because we did things. Yeah, alright. I'm just being dumb. Alright, let's see what that looks like. How come the inner color isn't coming out? Because we're not multiplying this out. Let's compile shaders. Yeah, so we have a much wider color spread in our waterfall now. We could change our exponent here. So this value here, we could make more black by like a, is there a POW? So we'll take this one and we'll take this exponent here. So let's take this and do a constant. Let's do like a 3 or something, and let's see what that looks like. Yeah, like power 5. That's looking better. Yeah, I'm liking that. Okay, so we'll promote this to a constant. I'm going to call this color exponent, and we got watercolor 2, so we'll go over to our blueprint here. We're going to duplicate this guy, call it watercolor outer, and watercolor inner. Can we reorder these things? There we go. Okay, so this will be the inner color of the falls. This will be the outer color of the falls. And then we'll need a watercolor exponent. This will be a larger value, means that outer color is pushed out further. So we're going to take this from 0 to 10 and default of 5. Alright, so let's set our scalar parameters here. So we'll get our watercolor, our color exponent, throw it in there. And the only way that any of these things people ever use them, like you can spend all day making complicated bullshit inside of programming land, and at the end of the day, nobody's going to use any of it unless it's got like nice little sliders or something else. So it's good that Unreal allows us to do that. And yeah, my brain just went straight off into nowhere land, pretty much. This will be watercolor 2. And we'll grab our watercolor outer, put it in there, and watercolor outer default we'll copy these. So let's compile and save that, and then let's apply these changes to our material properly to our waterfall. So there we go with our kind of edge color change, because we can. And I'm sure we'll be able to use it with something. I'm sure. And it would be interesting to have some sort of rippling effect on the outside of this, right? Like, we've got this inner and outer thing, but this waterfall is so uniform that we might be missing out on a few things. Like this waterfall, you can see the edges are a little divoted at times. And that needs to fall and flow along the edges. So we need like a noise to the edge of the waterfall as it comes down. So we can't have a straight edge here for everything. We need like, you know, nice little divots and stuff like that. And we want that noise to flow down at the same speed as the water. But how exactly do we want it to work? Like, we could have different types of noise to it. Let's comment this. This is map texture coordinates into global space. Create UVs and curve them. So how exactly would we do this? Like, we want to basically take these edges and have something that messes with the curve of this thing. And this is kind of the math that we've got for this guy. And I mean, we could do something like, you know, this, where we've got, you know, the both sides and everything inverted nicely. But we definitely need this. Yeah, we definitely need this. We basically want to move this waterfall offset inward. If we just move the waterfall offset inward, that's not really good enough. Like, I mean, the other thing is we could cut holes out of it. I mean, we don't exactly want to cut holes out of it, though. We're not cutting holes out of it. We're, like, squishing it for a certain amount. And we're changing how the squish goes. Yeah, I guess we are kind of changing the squish, but it's kind of a, it's also, yeah, it's going to be a noise reflected on the current value. Yeah, in our picture from before, we actually have this waterfall here as well, which comes down. Kind of like that. And that's why we're doing this in world space, so we can do all sorts of stuff with it. see if we can make this look like it makes a little bit more sense. To have a waterfall come down, like, you know, something like this. That looks all sorts of fucked up. That's because I don't have any of the surface normal stuff. Alright, which is something I'm going to need to add, so I need to write that down when I add it. Get the normal rotation properly. So we need to basically pass in basis vectors and do the multiplications for those sorts of things. So this would look correct if we had some sort of shelf that this was coming off of. Sort of like if there was water and it was going around and doing all this stuff. That looks really messed up. That planar reflection capture, not including the water right behind it. What is that about? Like, it's got the water there, but it's not stopping it from doing anything? Let's see if we flip this around, if that does anything. Nah, it's not stopping the light. Well, that's no good. So what light is actually causing this problem? It needs to cast shadows, is what's going on. Ooh, that's not good. That's in fact very bad. We can't cast shadows onto this water, I don't think, because it's this this test water is using test water 2. Let's actually snag that and throw it into our water. Let's copy it. Alright, so let's call this test water surface. And I'll need to rename it again. Test water surface material. So if we open this up, it is an opaque default lit thing. So it should get shadowed. So we should see the shadow of this object come down on it. So this waterfall blueprint 2. Dynamic shadows. Maybe we have to do a build of lighting in order to actually get some sort of shadows working properly on this object. I mean, if it's not something, it's another, right? We're just always running into small glitches and issues. Yeah, like it's not shadowing, is it? And if we have like a movable rock here, we'd expect it to be in shadow. Right here, right? So the waterfall material is lit, it's two-sided. Is there anything with shadows? Translucently scale, cast shadow is marked if true, forces translucency to cast shadows as if the material were masked. Alright, let's see. if on our waterfall mesh there is like cast translucent shadows. Well, let's see if this thing, if we do cast shadow as masked, if we can actually cast a shadow from this object onto something behind it. It's definitely that this thing is just not casting shadows. Alright, cast shadows, translucent object, and let's see. Cast a dynamic shadow from translucent mesh. So I think there's also another thing here where the forward shading model has to be applied for us to actually cast shadows from a translucent model. I remember something about that where we were not able to do any of this translucency stuff unless these objects were actually there. Otherwise we had to use the masked mode on these things. So let's see, use with static lighting. Uses distortion, forward shading, high quality reflections, planar reflections. Cast shadow as mask, diffuse boost. Let's see if we can use it. Yeah, the other thing we could do is have another mesh here that uses a different material, which actually casts the shadow onto the world. Let's just make sure that this is working at all. If we have a big object like a rock, you know, we don't have the sun bleeding through the rock, obviously. That works properly with lighting and casting shadows. So this thing is not casting shadows properly. So what I'm going to do is I'm going to save this. I'm going to save everything real quick. And I'm going to go to my settings here for project settings. Let's do forward shading. Let's turn it on and restart the editor. So we're gonna have to compile some shaders here to see if the forward shading actually fixes the casting of shadows from translucent objects. Otherwise, yeah. So we need a couple things here: panning the texture. We need shadows properly cast from waterfall. Which kind of sucks. Like we got this waterfall here that's all like transparent, but it's, you know, like we can't have nastiness happening here. Sure, it's a reflection, but we do need shadows as well. And I tried the volumetric translucent shadows, it's doing jack nothing. So, grrr. And this initializing here it's actually compiling a whole bunch of shaders here. Like I can see my CPU usage is at 100. I've got my keyboard here has one of those like CPU usage meters on it, so I can see what's going on my computer without actually having, you know, to pull up Task Manager. I would totally recommend having a piece of equipment on your desk that does that. It is very handy. Because it's got CPU and RAM, just bam, with the bars on it, and usually works real cool, real well. Yeah, so we got to compile a bajillion shaders. So that's our universe at the moment. The rendering nearly broke a stream. Yeah, that's why I've got that 16-core computer here. I'm using 100% of CPU, but I'm still streaming at 1200p. So there's almost no way to lock this computer completely up. The only thing I've seen that actually is able to lock up this computer was when the operating system got stuck reading from a disk drive that had a driver bug that completely locked up every single thread on a Windows call. It didn't happen all at once. It would just slowly lock a core whenever any of them were blocking on Windows function. So it was like slowly the computer, like, just things stopped responding. So we'll keep compiling all these shaders, and right now we're inside of this. I mean, you can see the sky sphere, right? When it looks like this, it's a big spherical object in the sky that you're moving around inside of the Dyson sphere. Like how we have the lighting from the rock is looking proper, but the lighting from the waterfall is not. And basically clicking that forward shading button means if you're running Windows XP, you can't play this game. So that's why we have not clicked that button yet. It doesn't look like it's working either here. Let's build our lighting. See if any of that fixes any of this crap. And it could be that translucent lighting, it could be this is a planar reflection. Planar reflections do not get translucent object lighting whatsoever. Just don't do it. They can't do it. It looks like forward shading just doesn't work with our object. Okay, so son of a bitch. So that forward shading button, probably we can't even hit it because it's not good enough. Like planar reflections aren't actually supported for it. Well, let's turn off forward shading and restart the editor. It doesn't have to recompile all the shaders all over again because it's got all those shaders cached for non-forward shading. Alright, so if we open up our stuff here, we go to our waterfall blueprint and our waterfall material and all that stuff. We've got our opacity and everything else. And let's see, if we go back to our checkbox, which is cast shadow as masked, we don't get an opacity mask option. So what I'm thinking is happening is you're just screwed for this object, and whoa, that's our sphere model with this thing rendered out. Anyway, so you do not want to cast shadows as masked. Refraction. Ooh, alright, so maybe we can do something with the refraction. Refraction is computed based on the camera vector entering a medium whose index of refraction is defined by the refraction material input. The medium surface is defined by the material's normal. In this mode, a flat plane seen from the side will have a constant reflection offset, but causes reading outside the scene color texture, so is a poor fit for large reflective surfaces like water. Okay, so what pixel normal? This refraction offset to scene is computed based on the difference between the per pixel normal and the per vertex normal. For this mode, a material whose normal is default 0, 0, 1 will never cause any refraction. This mode is only valid with tangent space normals. The refraction material scales the world. Well, let's see if that we have better refraction. Maybe this refraction mode was actually causing our weird, crappy stuff at the bottom here, because it said this is not good for water. So if we go to this waterfall and we say what's our refraction amount, yeah, doesn't seem like it does really anything. Alright, well that's fine. I just like how we have this giant driving sheet of angry water right here. It's like, ah, here's a nice relaxing. Ah. Alright, so we need a masked object here for casting shadows. Otherwise we're screwed. So why don't we duplicate this, and we'll do test waterfall mask.